Moving on to lesson 3.6, writing and graphing direct variation equations. So direct variations are similar to linear equations, except for basically there's no y-intercept. It's always going to be going through the origin. Direct variation is in the form of y equals a times x. The constant of variation is the a. In order to have an equation for a direct variation, all you need is the a. So for example, if the direct variation was 2, it would be y is equal to 2x. And my constant of variation would be 2. And that is an equation for direct variation. So how do you write a direct variation equation? Step 1, find the constant of variation. Step 2, rewrite as y equals ax, where a is equal to the constant of variation. This is a pretty simple, straightforward concept. How to determine if a function is direct variation? Divide y divided by x if y divided by x is the same for every point, then you have direct variation. So, it says check to see if the table represents direct variation. Well, we're basically going to take y divided by x. 18 divided by 3 is 6. And then we do the next one. 42 divided by 7 is 6. 96 divided by 16 is 6. 138 divided by 23 is also 6. Since these are all the same, our function does represent direct variation. Looking at example 2, we have 150 divided by 10, which is 15. Then 195 divided by 13, which is 15. 270 divided by 18, which is 15. 330 divided by 22, which is also equal to 15. So in this case, this one is also direct variation. Okay, now on to the more important stuff here. So we are going to talk about writing equations for direct variation. Remember, when you're writing an equation for direct variation, all you need is the constant of variation. And there's a very easy way to find the constant of variation when you're given some information. So it says y varies directly as x. So that means we're going to have an equation that looks like this. It's direct variation. When y is 7, x is 28. Find the constant of variation and write an equation of direct variation. Well, if we know what y and x are, and we need to find a, we can use that information to figure out what a is. So we have y is equal to 7 equals a times my x, which is 24. And then I need to find my constant of variation. Divide by 24, divide by 24, and we are left with a is equal to 7 over 24. We are not done yet because we haven't written the equation yet. If I wanted to rewrite my equation, I would just need to write y is equal to 7 over 24x. I fill in for what my a is. So now, if I wanted to say, okay, well, what does y equal when x is 20? I now have an equation that I can plug 20 into to find out what y would equal. Same thing for example 4. It says y varies directly as x. When y is 6, x is 10. Find the constant of variation and then write an equation. Well, in order to find the direct variation equation, I need to find the constant. So in order to solve for a, I divide by 10, and I get a is equal to 6/10 or 3/5. So when I rewrite my equation, I have y is equal to 3/5 x. Okay, moving on to a real-life example here. It says explain why c varies directly with t. Well, we know that when y divided by x is constant for every single set of coordinates, then we have direct variation. So let's see if that's true here. So we have 36 divided by 2, which is 18. 54 divided by 3, which is 18. And 90 divided by 5, which is 18. So since each of these divided is constant, we do have direct variation. So we would say yes, because y divided by x is constant. Okay? In order to find our constant of variation and to write an equation like letter B is asking us to do, we are going to do exactly what we did before. We are going to treat our number of tickets as x, and our cost is y. So in this case, it would be c, or y, equals a times t. So now, we're going to plug in for c and t. So it doesn't matter which point you use. Let's go ahead and use 90 and 5. 90 equals a times 5. Divide by 5, and you get that a is equal to 18. So my equation is going to be y is equal to 18x, or in other words, c is equal to 18t if we're going with the terms that we're working with here.